You notice I'm using just a side background fun thing. I'm using Zoom through Firefox right here instead of the Zoom app on this particular laptop. I don't have any non-open source proprietary ththings installed on this laptop. So I don't have Zoom installed, do it all through the web app. I had the issue that I posted to GitHub about my recommended way of connecting to the VPN here through the Open Connect program. A number of you were chatting before class here. Seemed like you tried it, but we're getting various errors with that. I apologize that you're not able to do that for whatever reason. It did take me quite a bit of time debugging exactly how the VPN was configured in order to get this command to work on my system. My system seems to have frozen except for the mouse here. Firefox, what are you doing? Oh, there we go. Saw a message about somebody being in the participants, but not there anymore. Okay, the Zoom session here, you're welcome to ever attend class on Zoom, or again, the class is all recorded, put on YouTube, watch them later if you would like to. Today we're going to do some quick background, more administrative stuff about the class, and then we are going to prepare ourselves for the lab tomorrow and the quiz next week. And we'll do that by going over the Unix, Linux command reference here and this quiz practice Posix shell 1 here. The quiz next week will be over this quiz packet right here and this quiz packet right here, one quiz on both of these packets. And probably won't get to this packet today, but by the time we have the quiz next week, we'll have covered all that. Yeah, another reminder about for lab tomorrow, there's the pre-lab work. You want to make sure that you have your various accounts on GitHub all set up for the lab. You'll also need to make sure that you're able to connect to the Lambda server in order to be able to complete the lab tomorrow. Today in class, if you're not able to connect to the VPN for whatever reason, you will be able to follow along with your local terminal, but the lab will have files on the Lambda server that you'll need to be able to have access to, so you'll need to have the Lambda server access for tomorrow. If for whatever reason you still don't have access and you need help, the IT help desk, CMC's IT help desk will get that straightened out for you. Any questions about Lambda server, VPN, what to do for lab tomorrow? Yeah.
Does it matter which lab we show up to?
The question is, doesn't matter which lab that you show up to, that when you were all enrolling, I tried to keep both of the sections for the labs reasonably balanced. The lab room, I think, has 35 seats, something like that in it, and there's 23, 24 people in each lab section. So if you showed up to a different one than the one that you enrolled for, then probably nobody will notice and everything will be okay. Good question. So that also reminds me that on our pull requests here, so one of the reasons we are using GitHub is because it allows you to submit corrections to the things that the class materials, and Ben has submitted a correction here to one of the things in the lab. And on GitHub, I can press this link right here to get what's called a diff between, this is the original file that was on this file right here, where I had a typo and one of my URLs was incorrect, missing this lab right here. So I can look at that really easily, say that, yes, this was a good change, fixed some stuff, made some things work. I will merge that pull request. And now that typo has been fixed, everybody has access to the corrected material, and Ben's got an extra credit point in the class. So a 1 out of 0, a record high score. Under the issues, again, there's posted some new announcement issues, and people have been asking questions through GitHub issues. That's really great. Very happy with how everybody has been using things so far. Okay, so with that, let's get right into our stuff for today. I'll be again, we're going over in class today. The main focus of class will be to go over all the material in this Posix Shell 1 quiz. This will be material on the quiz for next week, and it'll be background things that you'll need to know how to do in the shell in order to complete the lab tomorrow. One of the purposes of the lab tomorrow is to help reinforce all of the sort of shell material that we're talking about in the quiz here. So you'll have a lot of different exposure to these concepts. If for whatever reason there's something very confusing to you about the stuff that we talk about in the shell here, in the quiz, then hopefully that will get clarified in the lab. The format of the quiz, what it's going to look like is there will be 8 questions. The questions will be taken from the questions in these practice quizzes that I have. 4 questions from this Posix Shell 1 and 4 questions from this Posix Shell 2. The quiz will be 100% open note. You can use any written non-electronic resources you would like. So strongly recommend that you have, as you're taking the quiz next week, this practice quiz right here in front of you, and this this cheat sheet right here for the shell commands in front of you. And the way to take notes in class today, as we're going over things, is to just write directly on these pieces of paper whatever is going to be useful to you to understand what all of the different commands do. I'm going to switch my terminal or my screen here in a second to this terminal, and we'll get started with things. But before I do that, any questions about anything administrative before we talk about material things? Yes?
If we can't collaborate outside of the QCL, are we allowed to study for the outside of the QCL?
Good question. So yeah, we haven't really talked about the collaboration policy yet in the class. So let's go ahead and do that. The way down here at the bottom of our README file, there is this collaboration policy and technology policy. So the first thing about this technology policy is that other professors might be scared of ChatGPT and all of these tools. These AI tools. In this class, the things that we're going to be talking about are, for the most part, way too complicated for any of those AI tools to really be of much use. So I think it's basically impossible to use those tools in a bad way. And so I give you unlimited access to ChatGPT or anything of that nature. You can use any electronic resource of any sort at any point in the class, unless it's like a quiz where I specifically said no electronic resources. All the programming assignments, so like labs and homeworks, you'll have to be completing those on the Lambda server. So again, today in class, as we're going over the quiz, it's fine to do that on your own computer. If you're on a Windows computer, the things that Windows supports will be a little bit different than the things that are going on up here. But if you're on a Mac, everything will be 100% the same. I mentioned a little bit before about you'll be having to use Vim for all your text editing. This will come up in a couple weeks when we start doing a little bit more programming stuff. And then last thing, technology-wise, occasionally students are tempted to, I don't know, share passwords or login credentials on the Lambda server with other people to make certain projects easier, but not allowed to do that. Collaboration-wise, so getting to the actual question, again, GitHub issues, highly encourage you all to post whatever you want there. Posting code is 100% acceptable. You can post your entire solution to an assignment on GitHub issues, and there's nothing wrong with that. So no restrictions on what you can use GitHub issues for. And again, there's been a handful of great questions on GitHub issues, so I'm encouraged that you all are going to be using that well. One of the reasons, again, why the collaboration policy and technology policy is designed the way it is that I want you all to be getting into good habits for when you graduate from this class and work on your own projects, or graduate from college and go on to your illustrious careers. You should be in the good habit of sharing lots of information, sharing your code with other people, because it will make both you and those other people more productive. And I don't want to have artificial restrictions just for academic sake, that I want this class to be very practical, very helpful for you in your careers. Okay, now the actual question in terms of collaborating with students. If you're working on something that is directly being submitted to the class, so like the labs or the homeworks, that has to be in the either here in class, in lab, in the QCL, or in my office hours. The main reason for that is that I want you all to be I want to encourage, one of my goals is to maximize the amount of collaboration that is happening in this class. And I found that this restriction actually increases the amount of collaboration that people do, because it makes people all come to the same place. And then you have a group of 10 people working on similar problems. And we'll see at some point in this, at various points in this class, that there'll be certain things that are very hard to get unstuck. And it might take one person 20 hours of internet research to get past whatever problem you're encountering. But if you have 10 people all slightly researching slightly different things, then it'll take 2 hours of internet research, and things will go a lot faster. So for the projects, anything that's with a computer that you're typing, submitting something directly to the class, has to be in one of these locations. In terms of studying for the quizzes, I don't want to put a restriction like that on for the quizzes, because then it can be, I don't know, while you're walking to class or other things like that, talking about the class, talking about the quizzes, that's certainly fine. If you want to work in your own dorms with roommates or other people, that's fine as well. I'd encourage you to still go to the QCL to do that, but not going to require it. If you have not been to the QCL before, it's CMC's sort of tutoring center for computer science math classes. It's over all the way on that side of campus where the cube is, the big glass box just in the floor below that. Last restriction here on collaboration is that you can't look at another student's code on GitHub. That if you're in one of these environments, it's okay to occasionally look at other people's screens to talk about code and what different things are doing. But again, all of your assignments are going to be submitted through GitHub. Your first homework assignment in this class is going to be walking you through some of the steps about that, why the course is structured that way. But all your code is essentially going to be open source things, and I want to again encourage good habits about developing open source software. One of those good habits is obviously making that software available, making it public, and I'm trusting you all just to not go look at other people's code and copy it from the internet, even though it's there. So a lot of things. Any questions? Yes. Excellent question about when are my office hours. I haven't posted them yet. I still have some other things that I need to get scheduled. My hope is that tomorrow before lab, that'll be finalized, and I'll be able to post it on a GitHub issue that tells you all my office hours. If for whatever reason before that's posted you need to get in touch with me, we can arrange a time to meet. Happy to meet right now after class, for example. But that should be posted soon. Yeah. Apologize for the delay on that. Good question. Any other questions? Administrative things? Okay, since we're here, one last administrative thing about accommodations. In general, we'll see that a lot of things in this class are designed to be very accommodation friendly. And one of the reasons for that is because it turns out that making things accessible for people who need accommodations makes things more accessible for everybody. And so in general, good software design is just good software design in general. And throughout the class, I'm going to be talking a lot about different things that relate to accommodations and good software design. So the first one of those that I want to talk about is related to one of these GitHub issues that was posted. Here, an excellent question about a problem using Git and encountering that problem. The thing that I want to highlight, though, from an accessibility standpoint, is that there's an image here posted to GitHub issues. In general, you never want to post images of text anywhere. To a computer scientist, to somebody who is working with computers all the time, images of text are about the grossest thing that there exists. And there's many reasons for that. One is that now that text is inside of an image, I cannot copy and paste your output from, if you have an error message there that I want to Google, I can't just copy and paste it. I have to actually manually type it. So that's a problem. Your font and coloring scheme can be hard for other people to read. So some people prefer light backgrounds, some people prefer dark backgrounds, and colorblind people in particular may not be able to read whatever colors you have selected. Even worse than colorblind is actual blind people, that if you have an image like this, then there is screen reader software that goes through web pages and reads what's on the web page. The screen reader software cannot read any of this text, and so images are inaccessible to blind people. Maybe even more importantly is that Google is blind, and so Google cannot read that text. And so if maybe there's some like really important discussion that's happening about some error message that turns out to be very common, and so a lot of people around the world want to be able to tune into this discussion and see what the fix to this is. But because the error messages and solutions are in text, now Google can't find it, and so nobody else in the world can find it. So in general, again, an accessibility principle is that we never want images of text. We should always have text in text form. And when you are putting error messages, anything from a computer output in text form into GitHub, into anything that supports Markdown, you should be using this, this code block style like this. We call this right here a code block. And this up here, inline code, that this gray background tells me that this is actual code, literal something that was literally typed into a computer or output from a computer screen right here. And the fact that this is in a code block tells me that there is a new line at the end of here, that there is a one concrete full line here. A couple of people, well, it's very common for people who are just getting started with communicating over GitHub to mix up these inline code and these code blocks using the wrong one in the wrong circumstance. And so one of the purposes of this first meet and greet thread down here was to get you all practice using code blocks versus the inline code. And here, the quotation marks needed to be, or I asked for them inside of code blocks. And so here's an example of one that's in a code block, but a handful of people put it in the inline code instead of the code blocks. So code block, lots of code blocks. So here's inline code. And so you can see the formatting is not as nice, and it needs to be with the triple backticks. Anytime you're outputting something that is a full line or multiple lines with the triple backticks instead of the single backticks. And again, that's all for accessibility issues. And again, making things accessible to disabled people also makes them more accessible for other people. It's a long way of saying that if for any reason you have an accommodation, let me know and I'll make the course, I'll adjust things however you need for that. Okay, any questions about anything else before we get onto the shell and the quiz material? Okay, all great questions that people have asked. So we're going to be going over the shell, the terminal. Up here, I've called this the Posix shell. Posix stands for the Portable Operating System Interface. And Linux systems and Mac systems, both Linux and Mac are Posix compliant. Windows recently, meaning I don't know, last 5-ish years, has been making a push to be more Posix compliant. Windows has become more Posix compliant recently. And so I don't know the current state of Posix on your Windows machines. Some of these commands may or may not work on Windows machines. I'm going to, so each one of these quiz problems that has a number of terminal commands, shell commands inside of it. I'm going to go over for about 5 or 10 minutes at a high level, just more background on how to use the shell down here, going over some of these commands and what they do. And then after we do that, we'll come back to this quiz up here and see what the quiz problems, how they all come together. I'm not screen sharing on Zoom. Then I should be. Yes, thank you. I apologize for that. There we go. Both important for people connecting over Zoom and for the class recording in case you want to go back and review any of the quiz material here. Okay, so right now I'm connected to the Lambda server. This thing on the left on my screen over here, it's in green, but the important part over here is that it ends in a $sign. This is called the prompt right here. And the prompt indicates that you will be typing commands that are shell commands into your terminal. And shell commands is, again, short for this Posix shell command. We're currently in the Posix shell environment. On a Mac system, you might have a % at the end over here. And on a Windows system, it can vary a lot. But the $sign is the most traditional thing. The % is traditionally used when you have like root access or you're in a system that has a lot more access than normal, and Macs have, by default, for ease of use reasons, less security setup than Windows or than Linux machines, and so that's why Mac, the default is the % sign as your command prompt. The stuff over here to the left doesn't really matter at all. It's just the fact that we have a command prompt over here and we're typing stuff in on the command line. The first command here, the ls command, ls standing for list, ls equals list, and that lists all of the files in the current folder that you're currently in. pwd stands for print working directory, and this tells you where you're currently located. Another command, cd, cd equals change directory. And we use the cd command very commonly to navigate around. So I'll just real quick cd into big data. I did this last time. And now if I type the ls command, I get different things. I'll pause for a second and just say the best spot to be taking notes at this point is on this cheat sheet. We're going over these commands right here under the file commands. And so just making sure that you understand what these commands actually do. And if you need to take notes about what they do, then this is a good spot to do it, so you have it all in one place. Any questions so far? How many people? This is all review of things that you've seen in the past. Okay, a lot of people, not quite everybody. Inside of, so on this cheat sheet again, so we saw the ls command by itself. There's, you can also pass arguments to any of these commands. So on the terminal, the thing that is the leftmost word that you type in, so the leftmost thing separated by a space, this is the name of the command, and everything else is the arguments to the command. One of the common arguments to ls is this -a argument right here. Here, ls by itself displays all of the files. Here we have 2 files in this folder. ls-a also displays hidden files. The A stands for all. So it displays all of the files. And in Unix systems or Posix systems, hidden files begin with a dot. So it's just an ordinary file name right here, but it begins with a dot. In every folder, every directory is going to have 2 special hidden files here, the dot and the dot hidden file. The dot hidden file is the more important one. That allows you to go backwards in your terminal navigation, and it refers to the parent of your current folder. So right now, my PWD, my present working directory, is /home/CSCI143 example. This is my current user account that I'm logged in as, and I'm in the big data folder. And if I do cd ... then I am back in this folder, which is the parent folder of this folder right here. I'm going to use the mkdir. mkdir stands for make directory, and I'll make a new folder right here called quiz. A directory and a folder. Directory and a folder are exactly the same thing, no difference at all, synonyms of each other. Old people, like people who were programming in the 70s, tend to use the word directory. People who are younger than 50 tend to use the word folder. Otherwise, they're identical. And then after I make this folder, if I type ls, now I can see there are 2 folders here, big data and quiz, and I can cd inside quiz, type ls, nothing exists inside of this folder. I type ls-a. Every folder always has these special files dot and dot inside of them. I'll do cd ... type ls again. And if I ever want to delete a folder, I can use the rm command. Rm stands for remove. Rm equals remove. Anytime you're deleting a file on the terminal, rm is the command to use. Here, if I type rm quiz like this and hit enter, then we'll get an error message right here. Notice that I know this is an error message, not something that I typed into the terminal, because this line right here does not begin with a $sign. All of these outputs up here, the location where I was typing things in, begin with a $sign on the prompt, and anything here that does not begin with a $sign is the output of the previous command up here. Here, the rm command, in order to protect you from doing something that you might regret later, will by default not remove folders for you. And if you want to remove a folder, adding this -rf flag right here will remove that folder. Now, if I type ls, then it's gone. On the terminal, on a Linux system, there is no like recycle bin, there is no wastebasket, there is no way of recovering files that have been deleted. So this is a fully permanent thing. Once you do this, you can't recover those files anymore. And so that's why it has this little safety check in here, that if you're deleting a whole folder, maybe that's not really what you wanted to do. So you have to add this other parameter right here, or argument, in order to get that to work. Another pause for a second. Yes?
What's the difference between doing that and just having a flag -r?
Question is, what's the difference between -r and this F here? I'm going to punt that question for a little bit, that it's going to take us down a rabbit hole that we might be able to have time for at the end of class. Yes? Oh, great question over here. So here I have a slash at the end of the quiz, and why is that? 2 reasons. The first reason is that this slash at the end of a file indicates that this file must be a directory. And if this file right here was not a directory, then we would get an error message. So putting the slash at the end is a little bit of a good habit thing to do when you're deleting directories, just to ensure that you don't have a typo somewhere. So that's one answer to the question. So quiz and quiz slash are treated 100% identically, 100% identical, but quiz slash slightly better practice. The more literal answer to the question, though, is I used something called tab completion while I was typing. So I'm going to type really slow right now, rm space dash rf space type the letter Q. And my fingers are lazy. I'm a lazy person. Hopefully by the end of the class, you all consider yourselves lazy people as well. That's one of my goals as an instructor, is to convince you all to be lazy people, because computer scientists should be lazy. That the whole reason we have computers is to have them do work that we don't want to do. And right now, I don't want to type UIZ because I am that lazy. And so instead, I'll press the tab character on, where's my, I'll press the, I deleted it. Type ls, make dir, quiz, rm space dash rfq. I will press the tab button on my computer, and it types out all the other things of that file for me. And the tab completion by default puts the slash at the end of folders because it's the best practice. So I agree, quiz was a short word. Maybe that wasn't all that lazy. But eventually, you'll have files and folders that are maybe 20 words long or that are hard to remember, and typing tab completion makes things a lot faster and easier that way. Another sort of a side thing is throughout this class, when I'm working on the terminal, I'll be doing a lot of terminal work in this class, a lot of sort of live coding about different things. I will do occasional asides about shortcuts, tools, things that I do to make my life easier, and you'll never be required to know those sort of things. So like this tab completion, that's never going to appear on a quiz, that's never going to be something that you absolutely must do in order to complete a homework assignment. But if you get yourselves into that habit of using some of these sort of shortcuts that I introduce, then your experience on the terminal will be much more comfortable, and the homeworks and labs and exams will all be easier for you. Does that answer your question? All great questions so far. Okay, a couple more things for us to see is this echo command up here. So echo is a weird command that all it does is print out whatever you pass in. So here, let's just try hello world like this, and it types out hello world down here. You notice that the quotation marks here, I type them on the shell command line right here. They do not appear down here in the output of the echo command. In the shell, so the shell is a full-fledged programming language. Shell is a full-fledged programming language. Anything you can do in Python or C or Java or whatever your favorite programming language is, you can do that in the shell. One of the weird things about the shell, though, is the shell has only one type. Only one type. And that type is the string. In Python, there's a technical aside. If this doesn't make sense, that's okay. But Python is what we call an untyped language, which means or a statically untyped language, a dynamic language, means that that Python, there's no compilation step at the beginning where you have to specify what all the different types are. But Python still has types because it has integers and floating point numbers, and you can create your own classes, and all of those things behave differently. But in the shell, there's no way to do any of that. There only exists the string. And because there only exists the string, you are not required to put quotation marks around things, because in other programming languages like Python, the reason we have quotation marks is to indicate that something is a string. But in the shell, if everything is a string, then we don't actually need those quotation marks. So that begs the question about why might quotation marks be useful sometimes. The first example we'll see here is that quotation marks let us indicate spaces. So we'll see that echo space quotation mark, hello, couple of spaces, world like this. We'll get some actual many spaces here in the output. But if we have no spaces, or no quotation marks, sorry, then all of these spaces will get collapsed down into a single space in the echo command here. Technically, the reason that's happening is because these will be considered two separate parameters to the echo program right here, whereas the quotation marks combine this into just a single parameter here. The echo command by itself, rarely used. It's usually used in combination with other things. And the first thing that we'll see for combining things together, let's see, ls, let's actually go into the quiz folder here. The first thing we'll see is output redirection, or these greater than signs over here. If I type echo hello world, I'll start with just a single output like that into readme like this. You'll see that the echo command no longer output anything to the screen down here because I added this greater than sign readme. In the shell, this greater than sign is pronounced output redirection, or redirect for short. So this is echo hello world, redirect into the readme file. If I type ls now, you'll see that there is a file readme down here. When I typed ls right here, before running this line, there was no file readme in this folder. The folder was empty. After running this line right here, I type ls, and this readme file exists down here. Output redirection will create this file if it doesn't exist, and whatever the contents of this previous program, whatever the output of this previous program was, it'll store in that file. The cat command is a standard tool for outputting the contents of a file. I can type cat readme, tab completion to make that faster. And here is the output of this hello world command right here. I can also open this file with any of the other file tools that exist. So like Vim, we've seen that so far, Vim readme, and hit enter. And now in this file in an editing mode, and we see it has hello world like this. So this is output redirection. I'm going to do another example here with output redirection. Here, notice that I'm not actually typing in all of these commands. I'm using the up and down arrow to navigate through my history of commands. What I'm trying to do is I'm trying to come back up to this command right here to rerun it. And so I'm pressing the up arrow to go back through my history of commands until I get to this command right here again. And I hit enter. And I type ls again. We still have this readme file. Type cat readme like this, and it still contains hello world right here. I'll press the up arrow again, up arrow, up, there we go, over to this. And now what I want to do is I want to change what's inside of these quotation marks to be something else, to output something else. You notice that when I use my cursor here in the terminal, it does not move where this flashing token is down here, where I'm actually typing things in. So I can't just like click down here and have the cursor move over there. Instead, I have to use my left button on the keyboard to go over here, delete that, and let's do some Spanish next. Hola mundo, and I hit enter. I type ls. We still have this readme file. I type cat readme like this, and now we no longer have hello world. We have hola mundo. So this single greater than sign, this output redirection, it deletes the contents of the file here, and then puts the output of the previous program into the file, replacing the contents of that file. If I change this from a single greater than sign to a double greater than sign, again, I use the up arrow to go back, left arrow, double greater than sign, run that a couple times, back up here, cat readme, then you can see that the double greater than sign does not delete the file, it appends to the file. So both of these single and greater than double than signs are called output redirection, but double greater than sign, appends, single greater than sign, replaces. I'll do this again to illustrate that again. Single greater than sign right here, cat readme, only one line now because we deleted that file. Do it again, cat readme, still only one line, up again. Now change it to a double greater than sign. Cat readme now it has two lines here because it's appending to the file each time. Any questions so far? I did a lot of things. Yeah. Question is, what is this? Your question's what happens if we have multiple? So if I were to run this right now? Yeah. So the great question. The question is, now that we have run with the append up here, creating this file like this, and now what happens if I do it with just a single one? Then we get just a single line. That the shell in general has no memory about what previous commands that you've run. The only thing that it knows is what currently exists in the files on the computer at this moment in time. So the fact that this last line right here contains just one output redirection arrow means that it's going to erase whatever previously happened. Good question. Yeah. Great question. So the question is, what happens if I get rid of the quotes here? And the answer is that let's first use echo by itself without quotation marks. And we see that the echo command by itself without quotation marks is going to give us the exact same output down here. And so now if we combine that with, let's call this readme 1 with quotation marks, readme 2 without quotation marks, cat readme 1, we can see it's all on a single line. Readme 2, we see it's all on a single line again. So in general, the fact that you're doing output redirection over here has no knowledge about what the syntax that you used about the command over here on the left. It doesn't know whether you used quotation marks or not quotation marks. All that it knows is what the output of this command is. And so if the output of this command is the same in both situations, then the file will be the same in both situations as well. Good questions. All great questions so far. Another sort of quick aside, maybe like, I don't know, a meta thing about my thought process in terms of how I go through these lecture notes. I generally try to go at a pace that I think that not everybody is going to keep up with. That my goal is that average student understands about 80% of the things that are going on in each of these individual lectures. If for whatever reason you feel like you are not understanding enough, please feel free to interrupt at any point and ask questions. There's many things up here that to have questions about. There's a very complicated environment, very different in many ways from Python or other languages that you've seen before. And so at this point, there really is no stupid question. So please feel free to interrupt me and ask questions. Why do I target this like 80% level about understanding in terms of the speed that I'm going? And the answer is that if you were, say, in like a Spanish language class or any sort of foreign language class, you don't want to be understanding everything that the teacher is saying, everything that your communication partner is saying as you are as you're talking to them. Because if you are, that means that person is talking too slow and you're not going to be progressing about things. The speed at which I'm talking through this, the things that I'm working through right now, this is probably about like, I don't know, 10, 20% of the speed with which I work when I'm on the terminal. And I'm, by trying to push you into an uncomfortable realm about that it's a little bit difficult for you all to follow along with everything that I'm saying, I'm trying to help build up your ability to work quickly in these sorts of environments. And so certainly by the couple weeks, everything in this first lecture will be second nature, and you'll be able to follow along really easily with this sort of stuff. But we're going to see some very complex, weird incantations here in a little bit, in a couple weeks. And you want to be able to have, you'll need to have very good speed, comfort, familiarity with these basic tools in order to follow along with those more advanced things. So that's why I'm pushing everybody's speed and trying to intentionally go a little bit faster than I think most people are necessarily comfortable with. Okay, One more thing for us to talk about before we're ready to talk about this first problem. So many things, and we haven't even talked about the first quiz problem yet. Okay. That is this grep command over here. So grep is a very famous command on the terminal. It's probably one of the most important commands. Without grep, the terminal would basically be useless. And what grep does is it's a searching and filtering program for us. I'm going to type grep on the command line here, type this grep hello, and we'll see exactly what grep does all by itself, and then we'll see what grep does when it's combined together with other programs. So I type grep hello, and you see that it gives me a little chance to type in stuff down here. I know that I'm not currently typing in commands because there is no prompt at the left-hand side of this thing. So if I were to type in something like echo hola mundo here, then we can see that this echo command did not get run. This hola mundo did not get output to the screen. Again, I know that this is not the shell environment right now because there is no $ at the beginning of these lines. So there is no prompt, so I'm not typing in shell commands. Instead, I'm in this grep environment right now. And what grep does is anytime there's a line that gets entered into it, if that line contains this text over here, then it will print that line again. If that line does not contain this text, it will not print that line. So echo hola mundo did not contain this line, but if I were to just say hello world, notice there is no echo command here, but still it got outputted again because in the grep environment, if the line contains this string over here it contained this string, it's going to print it out. So this is a example. Should be an example, but that's okay. Doesn't print anything out. But if I say this is a hello, it will print that out again. By itself, grep does not seem like a super useful thing, but it becomes very powerful when it's combined together with other tools. That's going to be a very common principle that we'll see about these shell programs is by themselves. They're all designed to be very, very simple things, but they can be combined together to do powerful things. Anytime you're in one of these environments that's not the shell environment, in order to exit that environment, you can press Control-D. So I pressed Control-D. Control-D on an empty line will exit whatever environment you're in, will exit the non-shell environment and send you back to the shell. On Macs, a common mistake for Mac users commonly press Command-D, which does nothing or maybe even makes your screen do something weird, but it should be Control-D even on Macs. So let's think about how to combine this grep program with these other programs. So we've seen this cat command before, cat readme. So here's what's currently in my file, just hola mundo. I'm gonna go ahead and delete this file and we'll run lines 2, 3, and 4 up here so that we have maybe a more interesting readme file for us to look at. So I'll type echo hello world into readme, echo hola mundo into readme, echo salve mundi, it's Latin, into readme, Latin for hello world, and then cat our readme file, and you can see that I have those 3 lines in here, again, because I'm using the double output redirection or the appending operator here to append those lines to each other. And what is going to happen here on line 5 is we're going to take the output of this cat readme file, and this vertical bar right here is called the pipe. I'm going to pipe that into the input of this grep function. So we saw before that the grep function, or the grep command, if you type it by itself like this, just gives you a spot where you can type things in. So I can type test, I can type hello, and it only prints out those things which match whatever I typed in. Press Control-D to exit. But instead of typing things in manually, I can use this vertical bar to get have this cat program sort of type those things in for me automatically. So if I type cat readme, pipe grep hello, We see up here that this is the contents of the README file. And so all three of these lines will be typed into the grep environment down here. And we see that only the hello world line contains the word hello. These other lines down here do not contain the word hello, only in other languages. And so those lines will not get printed. Only this hello line will get printed. So I said before that grep is used for searching or filtering from and this is how it's used. You combine it with this pipe operator. You have some output of a program that you want to search through or filter, and you pipe that into the grep program here with a string that you are searching for. Any questions about grep or any of that stuff? Yes?
So when you pipe into the grep program?
Great question. The question is, or the observation is that when I piped into the grep program, it did not keep me in the grep environment. And that's correct. Anytime you use this pipe operator, you will not be placed into the environment of this program over here. Technically, what Control D does is it sends the EOF, standing for end of file, message to the program. And so the cat program, after it's printed everything out, sends the end of file message. So it's like it automatically presses Control D for us. And that's going to be universal for everything that uses the pipe operator. No matter what we have over here on the left, it's always going to send, the pipe itself will send the end of file message when this program is done. And so we'll never be left in the environment over here. Great question. Any other questions? Okay. We finally talked about all the things that we need for our first quiz problem, so let's go ahead and do our first quiz problem. Maybe to keep things a little bit organized, one last command that I'll type in here on the terminal is this reset command. Reset resets your terminal and gives you a nice clean working space. So notice it cleared the screen. My scroll bar here over on the right-hand side no longer lets me scroll way back up. It deletes all my history. It's like I've logged into a whole fresh new session. And now on these problems, you can see the problem statement up here. Problem 1, it says, write the output of the final command in the following terminal session. If the command has no output, then leave the problem blank. So there is no way to not answer these questions. By not answering this question, you are implicitly stating that you think the command has no output. And what we have to do is we have to type in all of these commands one at a time until we get to this last command down here and predict what the output of that command is going to be. On this first line up here, we've seen all these individual commands of cd, rm, make, dir. What we haven't seen is the semicolon. The semicolon lets you combine multiple commands onto a single line. And so this will run all 4 of these commands for us immediately at the same time, one after the other. Maybe what we haven't seen is the cd command all by itself. We've seen cd with a folder, something like cd ... cd quiz. If you do cd all by itself, it takes you back to your home folder. Cd with no argument takes you back to your home folder. So in this case, while we're inside of quiz, cd ... and cd by itself are exactly the same. The purpose of these first 4 commands is going to give us a fresh quiz folder, like a fresh environment for all of these problems. So cd will take me back to my home folder. rm-rf quiz will delete whatever quiz folder existed, maybe from a previous problem or just something that you were practicing with. mkdir quiz will make a new quiz folder, and then we'll cd into that quiz folder. Hit enter, and we're now in a totally fresh, empty quiz folder. This will always be the first line of every problem on this quiz. And all this line is doing, the summary takeaway of this line, is it's just putting you in the quiz folder that's totally empty, totally fresh. This first line is not intended to be tricky. The next line, using our echo, hello world, read me. So we've seen this a little bit so far. Hola mundo, read me. Echo salve mundo, read me. And then this last line, cat read me, pipe grep hello like this. We have this output right here of hello world. And so on the quiz, you would write down here, write the words hello world. And if you wrote that, you would get full credit. And if you wrote anything else, like just the word hello or just the word world or left it blank or doesn't matter what else you wrote, you would get the problem incorrect. Any questions on the format of the quiz problem or the contents, administrative things, anything at all? Okay. We have about 20 minutes left in class, and the rest of class I'll go through more terminal stuff down here. I'm not going to go through quiz problems directly up here, but all of these quiz problems, they increase in difficulty as we go through, and they introduce new different techniques. The way to study for the quiz is to, by looking at these quiz problems, predict what you think the output is going to be, and then after you've done that, type it into the shell and see if you got the correct output or the incorrect output. Okay, so the next thing we'll take a look at is piping with this WC-L command. So here, line 5, problem 3, we can see that now we don't have just a single pipe operator, but we have multiple pipe operators. It turns out that in the terminal, you can have as many pipe operators as you want, and it always takes the output of the thing on the left and feeds it as input to the thing on the right. So that begs the question, what is this WC-L thing on the right? What does it do? Well, WC-L, we saw this a little bit before, that it tells you the total number of lines in the file that you put over here if you specify a file name as one of the arguments. So the README file here has 3 lines. You can see that by outputting the contents of the README file with the cat command. And when I do WC-L README, it tells me that this README file has 3 lines right here. If you do not specify a file over here, if I were to just type WC-L, then I'm now in this WC environment, this word count environment. And however many lines I type in here before I press Control-D is how many lines will get passed to WC-L. In this case, there were 9 lines that I typed in, and so we get the output 9 over here. Anytime you have a program that can take input from the terminal, you can also pipe that input from a previous program. And so here we could do cat readme. Again, this outputs the contents of the readme file to the screen. I can pipe that into the WC-L program like this, and it will tell me that there are 3 lines in this file right here. What problem 3 up here is asking, though, is it has the grep right here in between the cat readme and the WC-L. In order to understand this program, I could type it all at once, cat readme pipe grep h pipe WC-L like this, and we get the answer 2 like this. But in order to help myself debug what's going on, why was this answer 2? The thing to do is to start from the leftmost command on these pipes. I type cat readme. Here's my first output here of these 3 lines right here. These 3 lines tell me what happened in all the lines prior to this line 5 right here. And then I can add just one at a time each of these pipe commands together. I'm piping to grep h now instead of hello. So any of these lines that contain just the letter h will get output to the screen. And here, so we have hello world output and hola mundo output. And now we only have a 2-line file at this point instead of a 3-line file. And so that's why when I pipe that to WC-L, I only get that there are 2 lines in that output. Any questions about that? How many people feel like at least 90% that made sense? Okay. It's all good. So with this grep command, I made a little bit of a white lie earlier. I said that the grep looks for this string anywhere the string appears in its input and prints that to the screen. That's not really what grep does, though. Grep supports regular expressions, supports regex. I pronounce regex as like regex. Some people say regex, but regex is short for regular expressions. The G is a hard G in regular, so I think it should be a hard G in regex as well. Well, yeah. I'll go on a lot of asides too about how people pronounce things in the programming world that oftentimes in just like a 5-minute conversation, I can tell like how experienced this person is in different tools just by the way they pronounce things. Do they say SQL or SQL? Do they say regex or regex? And I am trying to, when I emphasize things like this, help you to convey to other people who are potentially snobby that you are the sort of person that will pass whatever their snobby test is in an interview and want to be hired because you know you're in the cool club of people who do things the way that the good programmers do it. So I say regex. grep supports regular expressions. And there's going to be 3 regular expression operators that you'll need to know throughout this class. They'll come up in quizzes a lot. I mentioned this a little bit if you took CS46 with me, but we basically ignored it. It was never on any of the quizzes. So now is a time, if you took CS46 and we're maybe tuning out some previous stuff because it seemed familiar, now is a good time to tune back in and make sure that this new stuff seems familiar or that you're acquainted with it. Here, this regular expression h.star_a right here. So if I type this cat readme and then pipe grep of h.star_a like this, we can see that there is no file, there is no line in my readme file that contains this literal string of .star and a. So, but grep is still outputting this hola mundo line right here. Why is that? The answer is because these are, this dot and this star are actually commands in this regular expression language. The dot right here, dot means match any letter. And the star means match 0 or more of those letters. So here, in order for a line to match this h.star_a command, has to somewhere have an H and somewhere have an A inside the same line with any number of letters in between. The dot here matches any letter and the star matches any number of those letters. So hello world up here, this H right here could match with this H right here. And so maybe we'd get hello, like you might think we might get a match, but there is no A anywhere else in this hello world line. And that's why it did not get output up here on this line. Hola mundo right here, hola starts with an H, ends with an A. The O and the L get matched by this dot star right here, so that's why hola mundo got output down here. Salve mundi has an A right here, but it requires us to have an H in front of that A. Salve does not have an H in front of this A, and so it does not match that line, and it only matches hola mundo. Part of the background for this course, I'm expecting some familiarity with regular expressions. This dot and this star will come up many, many times in this course. If it seems confusing to you, it should not take too much background reading to understand what the dot and the star are. Let's see, it's the Foundations of Data Science prereq that covers the regular expressions. I don't know, most people, at least after some practice with the dot star, that is okay. But we're going to see here in problem 5 a new thing that this is definitely not talked about in CS46 at all, that is going to be confusing to people throughout the entire course. So it's a good time now to try to really make sure that you're understanding what's going to go on with this problem 5. Here, what I have, so with grep, I'll just type the command and we'll run it here for a second, and then we'll talk about what exactly happened. And let's reset my screen. It's cat readme, so we have that output, and then cat readme pipe grep-e h vertical bar a like this. What's going to be confusing here is that I have a vertical bar inside of this string. This string represents the entirety of my regular expression, and this vertical bar right here is inside of this string. That means that this vertical bar right here is part of the regular expression and is not the pipe operator. This vertical bar right here is part of the regex language and not part of the shell language. The thing that's going to be confusing here is when you're looking at these commands, trying to determine, is this part of the shell or is this part of the regular expressions? And we're going to be doing a lot of this in class where we're writing one language inside of another language, and keeping track of all that's going to be confusing. I'm going to hit enter right here. We'll see what it does, and we see that it prints out everything to the screen. Why is that? This vertical bar right here in regex is called the alternation operator. Alternation operator. In regex, vertical bar is the alternation operator. And that's a fancy way of saying it just means or. Vertical bar means or. And so this grep command is going to find any line that contains the letter H or contains the letter A. And every one of these lines contains one or the other of those letters. Hello world contains H, Hola Mundo contains both of them, but that's okay because it contains one of them. And Salve Mundo contains the A over here. And so this alternation operator like this selects everything. The -E over here, technically grep-E enables what's called extended regex. And so the alternation operator is part of this extended regex. You can, without the -E, escape it. \bar like this is how you do the alternation operator without the -E. If it's not \, if you just have this without the -E, then the vertical bar is treated like a literal vertical bar. It's looking for lines that contain the vertical bar, and so this finds nothing. So the -E means that vertical bar means or, -E means vertical bar means or. No -E, you need a \, vertical bar to mean or. No -E, if you just have a vertical bar, it means literally find the character vertical bar, find the pipe character. So H doesn't match, A doesn't match, H, A doesn't match, A pipe A, that does match. Anything H pipe A does match. The confusing thing again here is that the vertical bar, it's going to change its semantics. It's going to change what it does depending on whether it is between commands or inside quotation marks for the grep command. Any questions about that? Yes. So the question is here, when I did grep H alternation A like this, why did H and A not match? And the answer is because when you have grep without the -E, grep without -E means that vertical bar is a literal bar, not alternation. So here, grep that, no -E means this is a literal vertical bar. If I have no -E, I want it to act as alternation. I need to escape it like this. Now I type H and it does print it out. A, it does print it out. Or H type A, that'll still print it out. If I add the -E flag right here, and the -E makes, again, E stands for extended. It's just simplifying the syntax. It turned out, so grep, it's a 50, 60-year-old program at this point, back in the day when it was first written. People thought that it would be more convenient to have the vertical bar mean the literal vertical bar, and that you'd have to do something like this to get it to match. They thought that would be more convenient. More recently, though, people realized that this is the more convenient syntax, having the vertical bar mean the operator, not having to escape it. And so that's why this is a flag that you have to add in order to make this be the regex command alternation. A lot of, very subtle things there to keep track of. And what's hard on these quizzes is that there are many, many subtle things to keep track of. If you miss any one of those subtle things, then the final answer is going to be wrong. I'll go here first and work up. Yes? Question is, with this, does .* still work? Yes. So for our purposes of the quiz, the only things you need to know regex wise are dot, star, and bar, and dash E only changes behavior of the bar. Yeah. So grep dash E, something like dot or A. This is actually going to match anything because here the dot matches anything, and so it definitely matches dot or A. If I have say H dot star O, so the word hello should match this. Hello will not match this part over here, but because hello matches this over here, if I type hello, it'll match. Or I can type salve, that will match because it matches the A, does not match this. If I type hola, that'll match either of them, so it'll print. Did that answer the question?
Yeah.
Yeah.
If you were to not, or if you were to do the grepy and then insert an escape character before the bar, would that make it? Would that treat it as like the bar?
Saying that?
Yeah.
Yeah. Yep, good questions. Yes?
The dot, would it only match like letters or will it match any character?
Dot matches any character at all. Yeah, not just letters. So there are many more details of regex syntax that let you match many more complicated things, matching things like only letters or only numbers or only spaces. You won't have to know any of those details for the quiz. At various points in the class, though, there might be some labs or homeworks that have complicated regexes inside of them that you might need to look up the weird things that are going on inside. But for the purposes of quizzes, I'll only ever ask you something that includes the dot, the star, and the vertical bar. Yes? Great question. The question is sort of an order of precedence thing. The vertical bar matches, it's like, it's all of this or all of this. It's not tied just to the most recent character. Let's see. That takes us through everything that you'll need for the labs, the piping, getting familiar with that's the most important. Next week, we'll finish up going over more of this Posix 1's notes and the Posix 2 notes for the quiz. If anybody has any questions about anything material-wise, administration-wise, anything at all, I'll stick around after to get those questions answered. But this is will be our end of the course for today. Yes, the accounts.
And I'll reach out to IT on my own for the issue.
What is your email address?
ATERENY25@cmc.edu.
No I right here.
Oh yeah, an I after the Y.
What? Is that how your last name's spelled with an I at the end?
Yes. It means from the village of Tereni.
In what?
Hungarian.
Hungarian. Okay, you should get something.
Okay, thank you so much. Have a great day.
The difference between the dot and the asterisk. Mm-hmm. So the dot means that it has to be matching a specific word. So if it's A, it has to be A once. Is that how it is?
Any letter exactly once. Yeah.
So if it's like two A's, then it has to be twice.
So.
Or should we just only think about it as the dots asterisk for now? Is my question.
So if we had your questions like, what if there's a dot, not a dot before?
Or if it's just dot and then it's AA, because you don't specify the asterisk.
Dot AA.
So it has to be two A's in order for it to print.
So here, if we do two A's, that doesn't match. But if we have BAA, that does match because the B matches to that dot. The AA matches to those A's.
Oh, so that's any letter. Oh, so it's like the dot is like any letter.
Exactly.
Okay, and
then here, if it was dot star, then it's any letter 0 more times. So since it's 0 more times, A by itself matches because any letter 0
understood,
times.
okay.
If it was a, say, B star like this, then AA still matches.
Because of the
ACA does not, ABA does.
yeah. Okay, gotcha. Thank you.
I'm trying to come into the class, but on Friday, it's on next Fridays, but I'm already enrolled in the second lab. I was wondering if I could switch to that, like on the portal.
Let's move out of the